Hello. Right. We're going to be looking at binomial expansion today, in particular the expansion of 1 plus x to the power of n, where n is fractional or negative. Okay, so make some notes, get your heading, lesson objective and dates in Welsh down, and we'll make a start. Now, you're familiar with the expansion of a plus b to the power of n. And if we just go through that, a plus b to the power of n. And when we expand a plus b to the power of n, we get a to the power of n plus n. Then we look at a to the power of n minus 1, so its power is reduced by 1 there. b plus n times n minus 1 divided by 2 factorial, a to the power of n minus 2, b squared, plus n times n minus 1, n minus 2 over 3 factorial, a to the power of n minus 3, b cubed. Got 3, 3 and 3, so it increases by 1 for b and decreases by 1 for a. Plus, if we write the general form, n choose r, x to the power of not x, we haven't got an x term here, a to the power of n minus r, b to the power of r, plus b to the power of n. So that's our general form of expansion. Today we're going to be looking more specifically at this form, 1 plus x to the power of n, where n is either a fraction or negative index. And when we expand that out using the expansion we've got above there, a is now 1 and b is now x. So we have 1 to the power of n, which is just 1, plus n, a is 1, so it's just b, which is x, and x, plus n minus 1 over 2 factorial, x squared, plus n minus 1, n minus 2 over 3 factorial, x cubed, plus, and if we have a general term, it's going to be n choose r, x to the power of r, plus an infinite number of terms because we're using a fraction. Now this is valid for the modulus of this value x. So it's the modulus of x, which means the positive value of x, less than 1. Which means we're looking at a range of values from minus 1 to plus 1. So if we have a quick look at an example, and I'm not going to give you a fractional index to start. I want you to try and expand this one for me. 1 plus x to the power of 4. Just so that we can remember how to expand simple terms. So if we use the expansion we've got above, this one here, 1 plus x to the power of n, all that's changed is n has now become 4. So that gives us 1 plus 4x plus 4 times 3, I use a dot as times, divided by 2 factorial, x squared, plus 4 times 3 times 2 over 3 factorial, x cubed, plus, we got one more term, 4 times 3 times 2 times 1. I'm using my dots to signify multiplication, or 4 factorial x to the power of 4. Oops. When we simplify, you get 1 plus 4x plus the 2 here will cancel with the 4, goes to 2, so 2 times 3 gives me 6x squared plus 3 factorial, or 3 times 2 times 1 will cancel with 3 times 2, leaving me with 4x cubed And the 4 factorial will cancel with 4 times 3 times 2 times 1. So plus x to the power of 4. Just something to note. Remember when we did Pascal's triangle? We had 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, then 1, 4, 6, 4, 1. If we look at this row here, and we compare the coefficients we've got when we expanded 1 plus x to the power of 4, we got 1, 4, 6, 4, 1. So our expansion has worked quite nicely there. Okay, so let's have a look at this example. Again, this is not a fractional or negative index, but it's a good one to practice on. So first, if we compare it to 1 plus x, the 1 stays the same, but instead of x we got minus 2x, and instead of n we got 3. So we got 1 plus n is 3, so 3 minus 2x plus, we got 3 times 2, we use a dot for times, over 2 factorial, and we've got minus 2x all squared, plus 3 times 2 times 1 over 3 factorial, and we've got minus 2x to the power of 3. So it's finite because we haven't got fractional or negative index there, and that's equal to 1, we've got just one negative, so it'll be minus 6x. We got minus 2 minuses multiplied together, so we're going to have a positive solution here. The 2 cancels with a 2 there, so you end up with 2 times 2, which is 4 times 3, which is 12. So we got 12x squared. We've got 3 negatives here, so we're going to have a minus. 3 times 2 times 1 cancels with the 3 factorial. So you got 2 times 2 times 2, leaving us with 8x to the power of 3. So that's our solution. Now we're going to try something a bit different. So our example this time, we have to expand 1 over 1 plus x to the x cubed term. So first things first, we're going to write it as something we can expand. So 1 over 1 plus x, that's going to be equal to 1 plus x to the power of minus 1. We can expand that. We've got our formula above here. So we've got 1 and x. The only thing that's changed here is n is now minus 1. So 1 plus, instead of n, we write minus 1 x plus minus 1, then minus 1, so minus 2 over 2 factorial x squared plus minus 1 times minus 2 times minus 2 minus 1 minus 3 over 3 factorial x cubed plus, we write our dots there to signify that we know it goes on, the series goes on. Okay, so we've now got, if we simplify, 1 minus x, got a minus times a minus, so it's going to be positive. 2 factorial cancels with a 1 times 2, so that leaves us with plus x squared. Here we've got a minus times 3 minuses, so we're going to have a negative. 3 factorial cancels with the 3 times 2 times 1, so we got x cubed plus. Again, validity. We take the x here in the brackets, so the modulus of the x, and that's going to be less than the value that we've got here, which is 1. So it's valid for modulus of x less than 1, which is the same thing as we said before as going from -1 to x to +1. Okay. So if we have a look at this example, find the binomial expansion of 1 minus x to the third, and then state the values for which it is valid. So we got 1 minus x to the power of a third. So instead of x, we've got minus x, and instead of n, we've got a third. So just use our expansion above. 1 plus, instead of n, we've got a third here, so 1 over 3. And we got minus x. Again, we're going to go to the x cubed term, plus 1 over 3. Now we've got 1 over 3 minus 1, so that's going to be minus 2 over 3, divided by 2 factorial, times minus x squared, and we need one more term, so we've got a third, minus 2 over 3, and then minus 2 over 3 minus 1, it's going to be minus 5 over 3, all over 3 factorial, times minus x cubed. Continuing on. So if we simplify that, we get 1 minus a third of x, or minus x over 3, either way you can write it. We got 2 minuses there and a third one, so we've got a negative number, so it's going to be minus again. Now to work this out here, I always find it best to work in the margins. So I've got a third times 2 over 3. We're not bothered about the sign because we've already dealt with that. And it's divided by 2, or times 1 over 2. So the 2's cancel. Because it's divided by 2, we can multiply by the reciprocal. And that leaves us with 1 over 9. So that's going to be x squared over 9 squared. Then we look here. We've got 2 negatives and 3, so 5. Odd number of negatives. So that means we're going to have a negative term here. Again, to work out this, I like to work in the margins here. So we've got a third times 2 thirds times 5 over 3 times 3 factorial, or 3 times 2 over 1. So we can multiply by the reciprocal, 1 over 2 times 1 over 3. And we haven't got any more numbers. So the 2's cancel, leaves us with 5 divided by 4 3's. So that'd be 81, or 9 times 9. So minus 5 over 81 x cubed plus ad infinitum. They also want us though to find the values of x for which this expression is valid. Now, as usual, we take our modulus bar, and we've got a minus x, so we put a minus x in the modulus bar there, and that's less than the value that they've given us there, which is 1. Modulus, though, means we're taking only the positive values. So this is equivalent to writing the modulus of x is less than 1, and that's job done for us. Good. So you might want to make some notes on this then. So hit pause, make some notes. When you're ready to have a look at the next example, hit play again. Right, for this example then, we've got, we'll need to expand 1 over 1 plus 4x squared, and then state the values which is valid. I think you're ready to have a go. So I want you to spend 5 minutes, have a go, and when you're ready to go through the solution, hit play again. But I think you're ready. Good? Right, first things first, we got 1 divided by 1 plus 4x to the power of 2. That's equivalent to 1 plus 4x to the power of minus 2. We can expand that out. We've got our formula above there. Instead of n, we've got minus 2, and instead of x, we've got 4x. So that gives us 1 plus minus 2 times 4x plus minus 2, then minus 2 minus 1 minus 3 over 2 factorial times 4x squared plus minus 2 minus 3 times minus 4 divided by 3 factorial times 4x to the power of 3. And we won't go beyond the third term. You'd be very unlucky to be asked to do anything more than that in an exam. So you got 1. We've got one negative here, so our answer is going to be minus 2 times 4, it's 8x. Then we got 2 negatives, so our answer is going to be positive. The 2 factorial cancels with the 2 there, and we're left with 4 squared, 16 times 3, so it's 48. X squared. We got 3 negatives, an odd number of negatives, so it's going to be a negative answer here. 3 factorial, or 3 times 2 times 1, cancels with 3 and 2, which means then we've got 4 times 4 cubed, so 4 to the power of 4, which is 16 times 16, 256 x cubed. Okay, good. Sorry I'm a bit slow. I've got Chelsea being thrashed 3-0 by Sheffield United, so it's quite interesting. Right, onward. So that's our expansion. The other thing we need to look at here is what's it valid for? So if our modulus, positive value, if we look here, we've got 4x squared. So we take the value there, which is 4. So the modulus of 4x is less than the 1 there. But I want the x on its own, so I'm going to divide both sides by 4. That means I've got the modulus of x is less than a quarter. That's job done for that question. Good. Right, for this example we got to expand 1 minus 2x, the square root of that, and then by using x equals 0.01 find an estimate for the square root of 2. Well, let's expand that first before we substitute for x and estimate what the square root of 2 would be. And then we'll check to see if our estimate for square root of 2 is accurate. So we got 1 minus 2x, the square root of it. Well, that's going to be equal to 1 minus 2x to the power, correct, a half. Now I think you can expand that, so hit the pause button, expand it, and then when you're ready to have a look at this, then hit play again. Okay, so we've got, using the expansion above, we got 1 minus n is a half, so a half, sorry, 1 plus a half times minus 2x plus a half, and then a half minus 1 minus a half divided by 2 factorial times minus 2x squared, and we use one more term, so plus a half minus 1 minus a half minus 1 minus 3 over 2 divided by 3 factorial this time times minus 2x cubed. Right, so if we simplify this, we get 1, the 2's cancel, we've got a minus there, so it's minus x. We've got 3 negatives, so our solution is going to be negative. Now to sort this out, I always work in the margin. I do a half times a half, and then it's divided by 2, so it's going to be times a half. We've also got 2 2's in the brackets there, so it's times 2 and times 2. We don't worry about the negatives because we already sorted that out. So the 2 of the 2's cancel each other out, leaves us with a half of x, or x over 2. Sorry, x squared over 2 even. Here we've got 2 negatives and 3 more, so we've got an odd number of negatives, so that's going to be minus. Again, I'm going to sort this out in the margin, so I've got a half times a half times 3 over 2 times 3 factorial, so it's 1 over 2 times 1 over 2 times 1 over 3, because it's 2 times 3. And then we've got 3 2's there, so times 2 times 2 times 2. Now these 3 2's cancel with these 3 2's on the bottom. The 3 cancels with the 3 there, so I'm left with a half again. Just x cubed divided by 3 plus. So that's our expansion, done in 2 lines. It's quite neat. Then part B says, using the substitution x equals 0.01, estimate square root of 2. Well, we know that the square root of 1 minus 2x is equal to this approximately. So we can substitute then and approximate. So that means the square root of 1 minus 2 times 0.01 is equal to 1 minus 0.01 minus 0.01 squared over 2 minus 0.0, that's over 2 there, apologies, that should be a 2, 0.01 cubed over 2. Now we're not adding any more, so this is an approximation, so we should write this as an approximation. This is approximately equal to. Okay? So now we can work these questions out. We got 1 minus 0.02, so that's the square root of 0.98. That's approximately equal to 1 minus 0.01 minus 0, we've got 4 zeros, 0.00005, and here I've got 6 zeros, 0.00005. So that means that the square root of 0.98, now that's the same thing as writing the square root of 98 over 100. Yeah, 0.98. It's approximately equal to, work that on my calculator, I get 0.9899495. Now, square root of 98, half of 98 is 49, which is a square number. Well, I can use that. That means on the top I've got square root of 2 times the square root of 49 as my numerator, divided by the square root of 100 as my denominator. That's very useful because now I've got a square root of 2 there, which I'm looking for. That's approximately equal to 0.9899495. I know the square root of 49 is 7, so I've got 7 root 2 on the top, and the square root of 100 is 10. That's approximately equal to 0.9899495. Now I can get the square root of 2 on its own by multiplying through by 10 and then dividing by 7. So let's write that over here. So I've got square root of 2 is equal to, oops, it's approximately equal to, let's get rid of those. There we go. That's better. Approximately equal to 0.9899495 times 10 and divided by 7, which gives me 1.414213 571. And it does pay you to keep it to this level of accuracy when you're trying to approximate the square root of 2, because it's non-terminating decimal. What I want you to do on your calculators is actually plug in the square root of 2 and check that approximation, see how close it is. And you can imagine if we'd done one more term, it'd be even closer. Two more terms, be even closer again. And if you look at our expansion, you can start to see that you can say what the next term is going to be, and the next term, and so on. Okay, good. Right, for this example, we got f of x is equals 2 plus x over the square root of 1 plus 5x. Find the x squared term, and then state the range for which the expansion is valid. So we've got to expand it and find the x squared term. So we've got f of x is equal to 2 plus x divided by the square root of 1 plus 5x. That's equal to, if we put them all on one line, 2 plus x times 1 plus 5x, so 5, to the power of minus a half. Now we need to expand that, well, we need to expand the whole expression, but in particular we need to use our formula to expand 1 plus 5x to the power of minus a half. That's going to be equal to 2 plus x. If I use square brackets here, then I expand this out, I get 1 plus n is equal to minus a half, so minus a half times 5x plus, I got that minus a half, and then I take away 1 from that, gives me minus 3 over 2 factorial times 5x squared. Now they want me to find the x squared term, so I don't need to go any further. So I can close my square brackets there. So that gives me 2 plus x times 1 minus 5 over 2 x. I've got 2 negatives, so it's going to be positive, plus, now to work that out, I've got 1 over 2 times 3 over 2 times the reciprocal of 2, and I've got 2 5s here. Nothing cancels out, so I end up with 75 divided by 8, and that's x squared. So if I expand, multiplying by my 2 plus x, I get, so multiply by 2 first, 2 times 1 is 2, 2 times minus 5 over 2 is 5x, and then 2 times 75 over 8 leaves me with plus 75 over 4 x squared, and then I multiply by x, plus x times 1 gives me x, x times minus 5 over 2x gives me minus 5 over 2x squared, plus, if I multiply x by the third term, I get a cubic term, which I don't need, so I'm going to ignore that. I'm going to stop there. So if I simplify this, it leaves me with 2's on its own. I've got minus 5x plus x, so minus 4x. Then I've got plus 75 over 4 minus 5 over 2 x squared, because those are two x squared terms. And I need to simplify that to give me my x squared term, which is what the question wants. 2 minus 4x plus 75 over 4 minus, got to double that to get it over 4, 10 over 4 x squared. So that means I've got 2 minus 4x plus 65 over 4 x squared. So the x squared term is given by, is equal to 65 over 4 x squared. And then they want you to state the range of values for which this is valid. Now with this one we've got two things to consider. we've got the 2 plus x. So for 2 plus x, it's valid for modulus of x. It's the x bit there. Oops, let's put this in brackets. It looks neater. Which is going to be less than 2. So that means it's valid for minus 2 up to 2. And then you got the second term, 1 plus 5x. So I've got 1 plus 5x. And that's valid over modulus of, it's 5x there, so 5x. Oops. Should be a straight line for modulus. Is less than 1, because we got 1 there. Now if I divide by 5, I get the x on its own, so it's x is going to be less than a fifth, which means that is valid for minus a fifth, less than x is less than a fifth. Now this range, minus a fifth to a fifth, lies within this range. So 2 plus x works over this range, but 1 plus 5x only works in this range. So that's a region of validity then. So you can write it like that, or you can write it like that. Either one of those is correct. Good. So make some notes, and we'll look at another example then. And finally, expand 1 plus kx to the power of minus 4. The coefficient of x is given as 20. Find the value of k and find the corresponding coefficient of the x squared term. Feel confident, hit pause, expand that, find k, and then find the coefficient of the x squared term. And then once you've done that, have a check here if the answer is correct. In the meantime, we'll go 1 plus kx to the power of minus 4. So if we expand that out, that's going to give us 1 plus, instead of n, we go minus 4 times kx, plus, we go minus 4 minus 1, so that's minus 5 over 2 factorial times kx squared. And it carries on. So that's equal to 1 minus 4kx, 2 negatives here, so it's going to be plus. The 2 here goes into 4 2 times, so that's going to give us 10k squared, x squared, and so on. Now, they tell us that the coefficient of x is 20. So that means that minus 4kx is equal to 20. Oops, it's the coefficient. Let's get rid of that x there. There we go. Minus 4k is equal to 20. So k is going to be equal to 20 divided by minus 4, which is minus 5. That's part A. For part B, we want to find the coefficient of the x squared term. So coefficient of x squared is 10k squared. But we know k is 5, so it'd be 10 times 5, so minus 5 squared, which is 10 times minus 5 times minus 5, which is equal to 250. Great, that was your last example. I'm sure you're relieved, and I'm sure you're excited now. You want to get on with some questions yourselves. So, questions for you to follow. So questions are exercise 4A on page 96. I'd say we'll have a go at all of question 1 and question 2 because they are the foundation, and then most of question 3, and then you're ready to start doing the exam style questions 4, 5, 6. There are only 9 questions, so it goes on to page 97, and 1 challenge question when you're ready. Good luck.